Hi everyone, my name is Pandan Gupta and I welcome you to the last presentation of the Data 606 capstone project titled Predicting Stock Prices Using Daily News Headlines. Going ahead, I have used the DGIA historical stock data. As you see here, here's this small snapshot of how the data looks like. The last column here is the label. So the rows which are assigned 0 are those days when the adjusted closing prices of those stocks had decreased. The rest of the days have been assigned 1. The second data set which I have made use of is the top news headlines on Reddit. As you see here, similarly, another column, label news, have been added. The same pattern, 0 and 1, have been followed. The same days when, if these news headlines did come on the day when the adjusted closing prices had decreased, those rows have been assigned 0 and the rest of the days have been assigned 1. As you see here, there are some rows which are assigned label news value 2. Those are the days when there is no listing of the stock prices of the DGIA data. Here is the train and test split. The ratio has been chosen to be 70-30. And here are the various columns of the data set. And I chose the ones lesser than 13th June 2017 to be training set. The ones greater than 9th June 2017 to be test set. In the similar pattern for the news data set, less than 700 index values, 701 index values were chosen as the training news, and greater than 700 was chosen as the test news. Here is the count vectorizer implementation. The count vectorizer counts the number of times the keyword appears, and it creates a matrix of token counts. Since we are dealing with textual data, this was the first step I thought should be implemented. And as you see here, after the fit transform method was implemented, there are 3,324 words, bag of words created by this model. And in the bottom is the vocabulary here. Next, logistic regression was implemented. It is a classification algorithm that is used to predict the probability of a categorical dependent variable. Before logistic regression, I thought to implement the TD-IDF vectorizer to get rid of the most commonly used words like a and the, and min underscore df and the max underscore df parameters here specifies the minimum and the maximum frequency. So only those words which fall under these frequency list would be considered further. And the logistic regression is giving an accuracy score of 41%. Yes, I believe that's not up to the mark, so I went ahead, tried a couple of other things. Here is an implementation of the naive Bayes classifier. It is a probabilistic classifier based on Bayes' theorem. It considers the probability of an outcome regardless of the correlations. The accuracy score here is 41.13%. Next, I implemented the random forest classifier, which is random sampling of training data points when building trees. And here it gives an accuracy score of 36%, way less than what naive Bayes and logistic regression was giving. So I went ahead, tried another algorithm, the gradient boosting classifier. It is a group of ML models that combine many weak learning models to create a strong predictive model. Here, the accuracy score slightly, like 0.3% improved as compared to the logistic one. It's giving an accuracy score of 41.47%. And going ahead, here, a multi-layer feed-forward deep neural network is implemented. It is inspired by the information processing of one or more neural cells, which are called a neuron. The system is trained using a supervised learning method, where the error between the system's output and a known expected output is presented to the system and is used to modify its internal state. That's how the model is trained. As we see here, the activation function is for the first two layers is sigmoid is used, and for the last layer softmax is used since we are dealing with a probabilistic classifier approach. As we see here, the loss is very less, so that means the model has performed really well, and the evaluate function is giving an output of 91.49%, so that's really good as compared to how the previous models have worked on this data set. This is the best output I have got till now. Next, LSTM was implemented. LSTM are recurrent neural network which are capable of learning order dependence in sequence prediction problems. As we see here, all news train and all news test, these are the two different training and the test of the news headlines, which are being trained in LSTM train and LSTM test. And going ahead, here we see the accuracy score of the LSTM model, and that's 39.86%, and with a loss of 0.92. Probably the loss is more, that means the error is more, and the accuracy score is not even close to 50%. So this model did not perform that well. Under conclusion and future work, I would like to say that the accuracy scores which I have achieved when I trained multiple models on this data set, that predicting stock prices is the most difficult. The best I could reach was 44% for most of my models, and the best it worked for multi-layer neural networks where it was 91%. And on an average, I would say that stock prices is the most difficult to predict. With respect to the future work, what I would like to do is I would like to answer further questions of predicting stock prices, linking it with company's background. So here my next step will be to answer questions like, what was related news of Apple's company since its stock prices dropped? Similar for Amazon and Facebook. If they are doing good these days, what are the relevant news headlines about them now? So that's all for my project. Thank you for listening.